In this video, we are going to see about the shunt series. In other words, it is called as current series feedback amplifier. We have come to the last type of the amplifier, which is shunt series feedback amplifier. Hence, I guess that every one of you will be familiar with the steps. As usual, our step 1 is going to draw the equivalent circuit for the given diagram. Here, the input and output is equivalent circuit is drawn using the Norton's equivalent circuit. Now, in the next step, we are going to obtain the expression for source current. By applying Kirchhoff's current law, or source current is going to be given as II and IF. So, where IF is going to be the beta, which is going to be the gain, into I0. And in the next step, we are going to obtain the expression for I0 in terms of II. So, the output current is going to be given as AI into II. And at the last step, we are going to find out the expression for input resistance, which is our ultimate aim. So, here we are going to substitute this final equation of I0 in the first equation, which is Is. Hence, RIF becomes Ri by 1 plus beta Ai. So, this is going to be the input resistance for the shunt series feedback amplifier. Now, what is our next aim? Yes, you are correct. We are going to find out the output resistance for the same. As usual, we are going to draw the equivalent circuit. When we come to the output resistance, always we said our current is going to be 0, and here the output resistance is going to be disconnected. So these are the two usual things we follow for all the feedback amplifiers by finding out the output resistance. Now, let us find out current in terms of V by applying our Kirchhoff's current law. So, our input current is going to be the voltage based on the resistance. So, input current is going to be given as II. Here it is the flow of the current, which is based on this beta I. So, now we know the expression for II and I. So now we are going to substitute the second equation in our first equation, and we are going to get the final equation as I into 1 plus beta Ai. Our next step, we are going to find out the expression for the output resistance with feedback. So the output resistance with feedback is given by voltage divided by the current. So we know already what is the value of the voltage, and as usual the current value. Hence, our final equation becomes R dash OF is equal to R O dash into 1 plus beta Ai with the gain divided by 1 plus beta Ai. So what is this Ai? Yes, it represents the open circuit current gain without feedback. This is small ai. And now what about this A suffix capital I? It is the current gain without feedback, taking the load resistance into account. We have already discussed about all the four amplifiers, namely the series shunt, shunt series, and shunt amplifier. So, we will discuss as together about the source signal, what is the output signal, the transfer function. We have already derived the input resistance and the output resistance for all these four amplifiers in our previous videos. So, in series shunt, both the input signal and the output signal is going to be in terms of voltage. Whereas for shunt series, it is called as current amplifier, and hence the source signal and the output signal is going to be current, and our input resistance is going to be the following values. In the series amplifier, it is going to be called as a transconductance. So the source signal is going to be voltage and the output signal is going to be the current. And the last shunt transresistance amplifier, we have already discussed, it is going to be the opposite of transconductance. So the source signal is going to be the current and the voltage is going to be the output signal. So all these transfer functions, kindly go through it well, and the input resistance and the output resistance we have already derived in our previous videos. Thank you.